I'm going to go through the 8.3 quick check, which is Le Chatelier's principle. And over here we have a picture of Henri Le Chatelier. So looking at the first question, it says identify the stress for each change, determine how the concentration of each substance will change, and the direction that the reaction will shift when each change are applied to the system originally. So we're going to go through. If I add some SO2, here's my SO2. Okay, so the stress is going to be too much SO2. Now, if there's too much SO2, that's on my product side, my equilibrium is going to shift back toward my reactants. So I'm going to be making some SO3. I'm going to be using up some of my SO2. And my SO2, because I added it, it's going to go up. It is going down, but it's not going to use up everything I added, so ultimately it's going to be up. If I add a catalyst, okay, adding the catalyst provides no stress, so there is no shift and nobody changes. Okay, I'm going to get to the same exact equilibrium, I'm just going to get there more quickly. If I remove some O2, okay, there's my O2 as a product, so now there's not enough, there's too little O2. And what we mean by too little O2 to maintain that same equilibrium. So my reaction is going to shift toward the products to make some more O2. And my SO2 is going to go up concentration, the SO3 concentration will go down, and the O2 again is going to go down because it's not going to use, it's going to not make up everything I took away. Okay, if I decrease the temperature, okay, decreasing the temperature, now we're talking about the heat, so there's going to be too little heat. Now, how can the equilibrium make up for that? Well, they can do the exothermic version of the reaction. So the reverse reaction creates heat, and that is a good way to come back to equilibrium. So now my SO3 goes up and my two products go down. Okay. If I decrease the volume, decreasing the volume now is going to say, okay, which of these sides takes up less room? So here I have 1, 2, 3 moles of gas, and here's only 2 moles of gas. Now we learned because of our beach ball there that every gas takes up about the same amount of room. So my stress is that there's not enough space, too little space, and my reactants take up less space than my products do. So I'm going to shift toward my reactants. So these chemicals go up and these chemicals go down. Now, under what conditions can the greatest amount of SO2 be produced? Okay, we're going to get the greatest amount of SO2. So we're looking at two situations here. One is temperature. Okay, so I want to get the greatest amount of SO2. SO2 is one of my products, okay, right over here. And so I want to try to shift to the right. So what can I do to my temperature to shift to the right? And I want to have too much heat. So I'm going to do high temperature, and that'll make it shift to the right. Okay, how about pressure? Okay, this side, on the product side, there's 3 moles of gas. This side is 2 moles of gas. If I want to shift to the right, then I'm going to have low pressure, okay, because if the pressure is too low, 3 particles of gas will create more pressure than 2 particles of gas. So I want to do low pressure and high temperature, and that will shift to make as much SO2 as possible. Okay, the second question. If I add some O2, here's my O2. If I add some O2, then my stress is there's too much O2. Okay, too much of my product, I'm going to shift back toward my reactants to use that up. And the question is, what is my concentration? Now, the concentration of a solid and the concentration of a liquid cannot change. If the question said, what is the amount, then I would say, yes, I have more solid and less liquid, but concentration of those will not change. I'm adding the O2, so that is going to be up. Now for mercury, okay, mercury is different. Mercury is a liquid, and adding a liquid or adding a solid will not shift my equilibrium. because it's not even in my equilibrium expression. So nothing here is going to change. If I reduce my volume, now reducing my volume says there's too little room, too little space. So reducing the volume, if there's not enough space, I'm going to shift to the side with fewer moles of gas. And this is important that I only want to look at my gas. So on this side I have 1 mole of gas. The other side, my reactant side, there is 0 moles of gas. So these guys, the 2 moles of liquid and the 2 moles of solid, they do not count. So I'm just going to say 1 mole, 0 mole. So if there's not enough space, I'm going to shift to the left. Okay, these don't change because they are solids and liquids. Okay, and my oxygen will go down a little bit. And if I remove HGO, okay, again, HGO is a solid, and removing or adding a solid is not going to change anything. So you're not going to shift my equilibrium. And so all of these will be unchanged. When the reaction mixture is heated up, okay, then the concentration of O2 increases. Is the reaction exothermic or endothermic? So here's what I do is I say, okay, when the reaction mixture is heated up, the concentration of O2 increases. I translate that in, am I shifting to the right or am I shifting to the left? And if my O2 increases, that means I'm shifting to the right. Now, if I have too much heat, if I'm increasing the mixture, heating it up, that means I have too much heat and it's shifting to the right. That means I must have heat on my left side, because if the heat is great, if I have too much heat, it's going to shift to use up some of that heat, which is to the right. So I know that my reaction is endothermic. So this kind of problem is sort of a guess and check. And said if the heat was on the left and I increased the temperature, then it would shift to the right and make more O2. And that works out logically. And those are the things for 8.3.